Good morning, everybody. So my attempt number 3 at doing the notes. Hopefully this one is not upside down or sideways, but we shall see. All right, so this is section 11.3, and we're going to introduce a new thing called slope, a new topic. Slope. Slope has a bunch of different names. The most common one is the rate and change of y divided by the rate of change of x. So change in y over change in x is the most common. The one we use the most. Change in y over change in x. So slope often is referred to as change in y over change in x. Often we'll also see it as rise over run. How far up does something go versus how far sideways does something go? Now when I say up, I mean up or down, right? Change in y, rise, over change in x, run. What it really does is it measures how steep the line is, right? So if we have a large slope, it's going to be a really steep line. If we have a low slope, it's going to be a really not steep line. Think about a hill versus a mountain versus a sheer cliff, right? The steepness of the line. So we're going to do an easy slope calculation, and then we'll actually learn the formula for slope. So determine the slope of the road. Well, again, it's going to be rise. So this road goes up 2, and then it goes over 30. So the rise is going to be 2 over 30, which we could reduce to 1 over 15. This is the slope of the road. Slope actually has a formula that we need to know. The variable we're most often going to use with slope is the variable m. So you'll see slope defined by the variable m. And there's a formula. M equals y2 minus y1 over x2 minus x1. And again, they give you the formula right here. This is the slope if you're given 2 points. So if they give you 2 points, they say, given these 2 points, find the slope of the line. Again, these points are x's and y's. This is the formula we're going to use. Now, don't let these little lowercase numbers freak you out. Those are just called subscripts. We'll talk about what those mean in just a minute. There are a couple things you need to know about a line. I need to get a different color pen, sorry. If a line has positive slope, it's going to go up from left to right. So positive slope, it's going to go up from left to right. Negative slope is going to go down from left to right. So if the slope is negative, right? A horizontal line has 0 slope. Think about it, right? If a line goes left and right, it doesn't rise or run. And a vertical line is the weird one. A vertical line actually has undefined slope. It has no slope. We don't say it has slope of 0, we say it has undefined slope. All right, so given a couple pictures, let's determine if the slope is positive, negative, 0, or undefined. Well, this is a vertical line, so we know that that has undefined slope. This line is going up, looking left to right, so we would say that this one has positive slope. So that's the first thing they're going to want you to do, is be able to find the slope or talk about the slope. Let's actually see if we can find the slope. Determine the slope by using the slope formula. We can actually do this using any 2 points on the line. So I'm going to pick a couple points. Let's see, I'm going to pick good points. There's one and there's one. So that point is 0, 1, and this point is 4, 4. Now there's actually 2 different ways to do it. The way they want you to do it is actually using a triangle this time. So if I draw a triangle, right, a right triangle, the side of this triangle is 3 units because I go over 3, and the other side of this triangle is also 3 units. So we would say the slope is 3 over 3, which reduces to the number 1. So you actually can draw a little right triangle every time to do the slope. There's actually another way to do it using points, so that's what I'm going to do next. So 0, 3, and it looks like this point over here is 5, 2. So I'm going to call this point x1, y1, x2, y2. So my formula says y2 minus y1 over x2 minus x1. 2 minus 3 is negative 1, 5 minus 0 is 5. So the slope for that line is negative 1/5. You can do whatever you're more comfortable with. You can draw a little triangle to do slope, or you can use the slope formula that we gave you. Over here, they're actually going to want you to use the formula. So they're giving you 2 points, and they want you to use the formula. Let's see, I'm going to do it once for you. I'll do number 8. Looks kind of ugly with some fractions. So again, this is x1, y1, x2, y2. So my formula is going to be negative 1/4 minus 2/3 divided by 2/5 minus 1/2. Yeah, unfortunately, we have to get some common denominators. Let's see, the common denominator on the top is going to be 12. So negative 3/12 minus 8/12 over, let's see, the common denominator on bottom is going to be 10. So over 4/10 minus 5/10. Let's see, negative 3 minus 8 is negative 11/12 over negative 1/10. And don't forget, when we have a fraction divided by a fraction, we just flip the bottom one. Those two cancel out. We get 111 over 12. Let's see, that should be able to be reduced at least in half, right? That's 50 over 6. Or 25 over 3. The slope of that line is 25 over 3. So I did the ugly one for you. So why don't you try these? And then when I post the answer key, you can check. So you try. So there are some special lines that we need to know about, something called parallel and perpendicular. And we talked real briefly about these before in a previous video. Parallel lines are lines that never touch. Parallel lines are lines that never touch. Right? If two lines are parallel, then they have equal slope. Parallel lines have the same slope. In fact, this line's really important. Parallel lines will always have the same slope but different y-intercepts. So again, parallel lines are lines with the same slope but different y-intercepts. They will never hit the same point in the y-axis. There's another type of line we need to know called perpendicular lines. Perpendicular lines intersect at 90-degree angles. So if two lines are perpendicular, they hit at a right angle. They intersect at a 90-degree angle. The slope of perpendicular lines is going to look a little bit weird mathematically, but it's really easy. They're actually what we call mathematically opposite reciprocal. Again, that sounds like a weird name. What it does is all you do is flip and make negative. So the slope of perpendicular lines are flipped negatives. Do you see that to do these two slopes, all we did was flip the numbers and make one of them negative. If this is negative 8/3, this is positive 3/8. That's if they're perpendicular. Remember, if they're parallel, they're the same. All right, let's look at an example. So first determine the slope to a line parallel and then determine the slope to a line perpendicular. Let's see. Well, if this slope is -3, my parallel line, I'm going to draw it with these little arrows, my parallel line will also be -3. My perpendicular line, again, remember -3 is really -3 over 1. My perpendicular line will be 1/3. All right, what if a line has undefined slope? Well, undefined slope means a vertical line. So another vertical line will also have undefined slope. Well, what about a perpendicular? Well, if my line's vertical, a perpendicular will be horizontal because that's how they have 90 degrees. So its slope is going to be 0. One more. If my line's parallel to this line, its slope will be 1/8. And if my line is perpendicular, its slope will be -8 over 1. So parallel and perpendicular lines are things that we need to be comfortable with. We need to be able to evaluate them, so on, so on. So a couple more examples. I'm going to do a couple and then I'm going to let you try. All right, so determine if these lines are parallel, perpendicular, or neither. All right, well, the slope of this line is 4. The slope of this line is -1/4, which is a flip negative of the first one. So these would be perpendicular. Those two lines are perpendicular of each other. Why don't you try 14 and 15? Once again, I will post the answer key so you can check your answers. All right, so one more example. I'll try number 16 and then you can try 17. Let's see, determine if the lines are parallel, perpendicular, neither. So this time they're not giving us the slope, we actually have to find the slope. So let me find the slope of line 1. So the slope formula says 16 divided by 6, remember this is y2 minus y1, over negative 2 minus 3. 16 minus 6 is 10. 10 divided by negative 5 is negative 2. So the slope of my first line is negative 2. Let me find the slope of my second line. Again, we're going to do y2 minus y1. Negative 12, be careful, negative gets a little tricky over there. So negative 12 minus 10 divided by negative 2 minus 3. Be very careful with your negatives when you're doing slope. This is negative 12 plus 10 over negative 2 plus 3, which becomes negative 2 over 1. So these two lines have the same slope, so they are parallel lines because they have the same slope. So why don't you try to finish the rest of these? Slope is something you definitely have to be able to calculate. Once again, I will do my best attempt to update this video correctly. Hopefully it goes on YouTube correctly. And I hope you have had a great spring break and having a good week when I'm not there. See you later. Bye.